no math.
See, you're too serious about that. So just,
The ones that are just. Never mind, I'm not gonna go there.
all right, any questions here? On 4850 should be quadrant 3, and I know on 6 you only had to find sign. I believe it was negative 3/5. Big Burns, any questions? All right, we're good then, everybody else? All right, from the other page, what page is that? The one that was due yesterday. Page 3, 540. 540. We got the good old Empire State Building over here. All right, Lane, help me out here. Flip around and give me the details. What's the angle of elevation? We're from the 13th floor, right? 128 meters up. Is that correct?
Yes.
So this distance right here is 128. So from here to here, 128. All right, what else they give me?
The angle of elevation of the top of the Empire State Building is 59 degrees, 20 minutes.
Okay.
And the angle of depression of the base is 40 degrees, 29 minutes.
Like that. Oh. All right, how far apart are the buildings and what is it? How tall is the Empire State Building? Is that correct? All right, for that one. All right, what do we gotta do? For this one, how are we gonna figure this out? And one thing I would tell you to do is we know that in this triangle that 128 would correspond to that side. And you're going to need this piece right here in order to find the other part of the height. So we're going to take tangent of 40 degrees, 29 minutes. And then opposite is 128, adjacent is x. So tangent of 40 degrees, 29 minutes equals 128 over x. All right, find what that is. Nearest whole number is fine. Okay, when you're doing that. Now 40 degrees, 29 minutes, depends on what you want to do. I mean, you can take 29 divided by 60. That's not 60. Okay, add that to 40. And tangent of that. Okay, now I'm going to have to end up dividing because after I multiply here, I'll have x times tangent. 40 degrees, 29 minutes equals 128. Divide by tangent. And I get x equals, what is that going to be? 128 divided by my answer. Let's go 150. Okay, I remember that's the first answer they give you. That's the distance between the two buildings. So you got 150 meters right here. Now to the top. Let's see here. Oh, we'll do that. That, and that. And I need to know what I'll call that y. And so now I got enough information to figure out that value. Tangent of 59 degrees, 20 minutes equals y over 150. So tangent 59 degrees, 20 minutes equals y over 150. And what do we get for that? When you do that one. What do you get?
253.
253. So y is 253, and if I so for the Final answer, you gotta add 253 and 128. So what is that? 353, 63, 70, 381? Okay, 381 meters. So the height, 381 meters for that one. All right, the next one is, I think I got it written down wrong. What was the next one? It's not 83, 89? 89. All right, take a look at what you got. Oh, nice. And then let's see, how do we solve this? What are we finding for 89? We are finding cool. Find the height of the second building. Okay, so that building over here. We know the angle of depression to the top, which would be this angle. We know the angle of depression to the bottom, which would be that angle. And now we got to find the height of that building. All right, how'd you do it? Cooper, did you get it?
I got it wrong.
You got it wrong.
Very wrong.
What
I
do you-
interpreted the problem the wrong way. I was thinking that the 67 was an angle of depression from that line at the top of the building, and then the 55 was. I was thinking negative 67, and then I was thinking 55 above that line.
Oh, 55 above that line?
Mm-hmm.
That would be angle of elevation.
Yeah. Yeah.
All right.
I realize that now.
Okay. All right. Hey, it's okay to make mistakes now. All right, Josh Martin, how we going to solve this?
I did the exact same thing.
Oh. All right, Madison.
I didn't get it right either. My picture was wrong.
The picture was wrong. All right. Anybody? Tyler's on fire today.
You flip the angle of depression to change the angle of elevation.
For here,
Oh yeah, that works.
so draw a line in here maybe?
Yeah, and then you have to do it for the other one too. You have to find the base with.
Whoops. And then for the base?
Yeah.
All right, so that, let's see here. That means the 67 right there, that would be 67.7 degrees. And likewise, the 55.8 could be here. And so you got 67.7, you got that, and then what are we gonna find?
So you're gonna say tangent of 67.7 is equal to 1250 over x.
All right, X will be that distance there. And so this is the triangle he's working with. Okay, and so we're gonna find that X. All right, go ahead and find that if you haven't already. And then we get tangent 67.7 degrees equals 1250 over X. And X equals, Maggie, what'd you get?
512.7.
512.7, we gotta confirm, so I'm gonna make it 512.7, that's good. 512.7, so that's the distance between, and then we can move that up to here, and if I look at this triangle, 512.7 is along the baseline, or the bottom, 55.8. I can let that be X or Y. I'll let it be Y. So tangent of 55.8 equals opposite, which is Y over adjacent, which is 512.7. All right, and what do we get for that? Cole, DeLuca, you got it yet?
I did it a different way.
Where's your calculator at? You just letting everybody else do your work for you?
Well, I have the answer.
Oh, you did it a different
I
way?
just did it a different way.
How'd you do it?
I didn't flip those angle of depression angles. I subtracted it from 90.
Use those in here?
Yeah.
Okay, gotcha. You watching? This is not a spectator sport.
So it'd be
Pay admission.
754.
754? All right, we agree with that? So now I gotta take 1250 minus 754. Okay, and it looks like it should be 496. Right around there. Okay, so that's how you solve those two. 93, I'm not even gonna bother with because I didn't mean to give that to you because it actually has to do with the two problems above 90 and 91, and we didn't go over those. So that, if you get that one, you kind of got to do, set up two different facts and then kind of substitute into those. So if you got that one, that's really good, but I'm not going to take the time to go over it. All right, I wanted, let's see where we are at. I want to finish up those guided notes from yesterday. And then we got to continue on. We'll get to the unit circle. I don't think we'll get done with the unit circle today. I know that's disappointing to a lot of you. I know. Very disappointing. We will see. And those are the answers. Okay. All right, reference angle. Is that something you recall from last year?
Yes.
I hear a one yes. I hear a one no. And Lane's kind of, but that's usually about everything. Okay. All right, so a reference angle. Couple key things. It's usually labeled theta prime. Okay. It is. Let's see. Oh, I didn't want that one. Positive. Always positive. Acute, which means it's less than what? 90. And it's formed by the terminal side of the original angle and the positive or negative x-axis. That's probably the one thing, if you make a careless mistake, it's with that. I'll explain what that means. So here, all of these theta primes, if you take a look, they have to be formed with the x-axis. You have to go to the x-axis. Okay, don't go to the y-axis, always go to the x-axis. Okay, for that. In quadrant one, the angle and the reference angle are always the same because it's already acute. Okay, so you don't have to worry about that in quadrant one. All right, in quadrant two, let's just think about this for a second. If this angle is 120 degrees, what is the reference angle going to be? Okay, what makes sense? If that angle is 120 degrees, Mackenzie, any idea what the reference angle is?
60 degrees.
It is 60 degrees. Okay, so that is theta prime because what do they have to add up to? They have to add up to, in this case, 180. All right, so in general, the rule here, you kind of did this in your head, is you're going to take 180 minus the original angle. 180 minus the original angle. But we also have to account for radians. Okay, we also have to account for radians. So instead of 180, if your original angle wasn't 120 degrees, but it was 2 pi over 3, your reference angle would be pi over 3. So in radians, you're going to take pi minus theta. You got to do that. You take pi minus theta. So if your original angle is in radians, you got to give me the reference angle in radians. All right, if it's in quadrant 3, what would be an angle in quadrant 3? Any angle. All right, so think about that. Aaron.
200 degrees.
200 degrees. So he says this angle right here is 200 degrees. What would be my reference angle if that angle is 200 degrees? Just looking at this, what makes sense? Gavin? 20 degrees. Okay, the reference angle is this angle right here. So the reference angle equals 20 degrees. In general now, theta prime, how would I write the equation, I guess? Like a general rule to get the reference angle. Cooper, what would it be?
Theta minus 180.
It would be theta, the angle, minus 180. Good, because that would always give us the positive. And if we are in radians, it would be theta minus pi. All right, good. Quadrant 3, excuse me, we just did quadrant 3. Quadrant 4. What's going to be an angle in quadrant 4? Any angle in quadrant 4. Okay, Nathan Moore.
320.
320. All right, that's our angle. What's our reference angle? Cole Rose.
40 degrees.
It would be 40 degrees. Okay, it's that angle right there. So we went 320. We got to go another 40 degrees. That's my reference angle. All right, what's my formula going to be? Formula. So just in general, so you computer programmers, you know, when you write the formula for it, you got to have the general case, right? Lane, what's my formula?
Is it the angle plus 180?
Well, 320 plus 180 would be 500.
It's not it.
Good point. At least it's good to recognize when you're wrong.
Yeah.
All right. So not the angle plus 180. It's this. Think about that. Moorhead.
360 minus theta.
360 minus theta. I'll agree with that. So you do a 360 minus the angle, you're going to be left with the acute angle. Or 360 is the same as 2 pi. So that's in radians. Got it? That's in radians. All right, so those are just general rules. More often than not, when it's given degrees, you'll be able to figure it out. But in general, it's helpful to have those rules. Okay, find the reference angle. Somebody stole my angle, 200. You killed me there. Who did that one? Wasn't he one slope? I already forgot. That was Hess? Yes, thanks.
You're welcome.
We already know that. All right, 200 degrees. Not that you have to draw everything out, but you need to make sure you understand what it's asking. The reference angle is that angle with the x-axis. Since this is 200 degrees here, you're going to take 200 minus 180, and so it's going to be 20 degrees. So that is my reference angle right there. All right, what's my reference angle for 5 pi over 3? Now, obviously, I've given it away, but what quadrant is 5 pi over 3, and how can we figure that out? And I'm going to keep stressing to you, do as much as you can in radians. Don't convert a degree to a radian. In the end, if you really are struggling, you can convert a radian to a degree to work it out. But the more you can work with the radians and figure it out, the better off you'll be in the end. Okay, in the end. Now for 0 degrees, that's 0 radians. 90 degrees is pi over 2, or you can think about it as 1/2 pi. 180 is pi or 1 pi. 270 is 3 pi over 2, or 1.5 pi. And 360 is 2 pi. What I like to do is I like to take the coefficient, compare it to the quadrants, and figure out where it's going to be. If my coefficient is between 0 and 1/2, it's got to be in quadrant 1. If it's between 1/2 and 1, it's got to be in quadrant 2. If it's between 1 and 1.5, it's in quadrant 3. If it's between 1.5 and 2, it's in quadrant 4. Well, what's 5/3? 5/3, not that you're ever going to write it that way, but you can just mentally think about it, is 1 2/3, which is bigger than 1.5. So it's in which quadrant? 4. How do I find the reference angle? For quadrant 4, you take 2 pi minus the angle. Okay, 2 pi minus the angle. And so my reference angle, theta prime, is 2 pi minus 5 pi over 3, which is 6 pi over 3, minus 5 pi over 3, pi over 3. Now, what's 5 pi over 3 in degrees?
300.
Who said that? How'd you get that?
It's 5 over 3 is equal to 60 degrees. 5 times 60 is 300.
I was hoping you'd say that. Okay, if you got to memorize those key ones. So pi over 3 pi over 3 is 60 degrees. And then it's just 5 times that. So 5 times 60 will give me 300. Okay. To me, that's the easiest way. Now, I'm not going to say that's the easiest for everybody, but just if you think about it in multiples. All right, you do you. No, you do C and D. Get one of them. Good. We get one. It's me, Maggie now. Okay. Oh, you fixed it? Yeah. All right. Peyton, you got it?
I have the first one.
You have the first one? What did you get for the first one?
65 degrees.
65 degrees is correct. 115 would be in quadrant 2. So we need that angle. So this right here is 115. So 180 minus 115 is 65 degrees. That's my reference angle. All right. Are you not done with D or are you stuck?
Stuck.
Stuck. All right. What are you stuck at? You know what quadrant's it in?
2.
Quadrant 2. Okay. How'd you know that? Luck?
Yeah.
All right. What's the coefficient? The coefficient is 3/4. Okay. Think about it as 3/4. Start at 0. This is 1/2. This is 1. This is 1.5. And then coming back here is 2. Just all in terms of pi. Like pi over 2, pi, 3/2 pi, 2 pi. 3/4, where does it fall in between? In between 1/2 and 1. So it's got to be here. And now, so the theta prime is equal to pi minus, whoops, not equals, pi minus 3 pi over 4. And so theta prime equals pi over 4, because it'd be 4 pi over 4 minus 3 pi over 4. So pi over 4 would be your reference angle in radians. Okay. All right, so that's C and D. E, 950 degrees. What's this reference angle? What is it, Josh? Come on, let's go. Come on. Too slow. Just 20. That was a test. You can done that. All right, so for 950, you don't know where it's at right now, do you? Okay, you're just trying to kind of think through this. So just subtract 360 till you get something less. Find the coterminal angle between the coterminal angle for 950. So subtract 360. What is the coterminal angle between 0 and 360? You got it?
I have the answer.
What's the answer?
30 degrees.
That's wrong.
Are you sure?
Okay. What's the coterminal angle? Did you figure that out?
230.
Okay, 230. I agree with that. Where are you getting 30 degrees at?
Because I'm bad at math. So,
Okay.
Yeah.
All right. I just wonder where you went.
Well, because I was thinking 260, but it's 360. So don't worry about it.
You're still bad at math.
Yeah, that's what I said.
Okay. You're not getting better either. Okay. All right. 950 minus 360 minus 360 is 230, right? That's the coterminal angle. All right. Now, that's in quadrant 3. The reference angle, okay, will be right there. for quadrant 3, you take the angle minus 180. So you're going to take, hold on here, coterminal angle equals 230 degrees. So I'm going to take 230 minus 180. So my reference angle is 50 degrees. Okay, 50 degrees. Okay, F. Don't succumb to the peer pressure and change it to degrees. Keep it in radians. I got to find the angle between 0 and 2 pi. Subtract 2 pi until we get there. Okay, well, 2 pi is equivalent to 12 pi over 6. So you take 41 pi over 6, and we're going to subtract 12 pi over 6. And that gives me 29. Well, that's still bigger than 2 pi. Well, since we converted 2 pi to 12 pi over 6, we're looking to get under 12 pi over 6. Well, just keep subtracting. And I know some of you are probably just going to do this in your head, which is fine, but I'm going to write it down, and I get 17 pi over 6. Still too big. So one more. 17 pi over 6 minus 12 pi over 6 is equal to 5 pi over 6. That's my coterminal angle. What quadrant are we in? Okay, cool. Quadrant 2, because it's between a half and 1. So that's going to be in quadrant 2. Okay, right there. That means that is equivalent to 5 pi over 6. So my reference angle equals pi minus 5 pi over 6. Pi over 6. Reference angle, positive. Has to be positive, has to be acute, has to be made with the x-axis. Okay, on those. So right here, that would be my reference angle. Okay, for that one. Questions there? Now, reference angles are used to help generate the unit circle. Okay, so we're going to go to the unit circle, that second page there. Okay, in it, the unit circle gets its name because it has a radius of 1, which just makes things work out really nice for sine, cosine, and tangent. So we're talking, so usually, well, not usually, always, the sine of an angle is the y coordinate over r, where r is the distance from the center to the point. Okay, cosine is x over r. Well, what is our r in this case? Our r is 1. So sometimes it's helpful for a visual. I'm going to drop the perpendicular down. The horizontal leg is x because the point here is x comma y. The vertical leg is y. So using that figure, the sine of theta is equal to what?
What?
Just y, because it's really y divided by r, but what's our r value? 1, y divided by 1 is just y. So sine, if you have a unit circle, and you know this point, the y coordinate is your sine. What is the cosine? It is going to be x over 1, which is just x. What's our tangent? Y over x. Opposite over adjacent. Cosecant is going to be 1 over y. It's normally r over y, but our r is 1. 1 over x for secant, and cotangent is x over y. Agree? Okay. So now those are the key points to build up this unit circle. I'll get to that picture there in a second. I'm just going to do a couple things here. We originally started with an equilateral triangle of length 2. Well, I'm going to flip this to an equilateral triangle of length 1 because of the unit circle. So we know if this is 1, 1, and 1, and I draw in a perpendicular, that makes this 30 degrees. What will be this leg? What will be that leg down there? That has to be what? Half. Has to be a half. And, all right, what is the, I'll call that y. What's that value going to be? Well, you may not know off the top of your head. Pythagorean theorem. Y squared plus 1/2 squared equals 1 squared. 1/2 squared is 1/4. 1 minus 1/4 is 3/4. Take the square root. I get the square root of 3/2. So for that figure that you have down here, and I have it drawn flipped both directions, but I think you have the one on the left, don't you? Okay. We want the hypotenuse to be 1 because that's going to be part of our unit circle. And that's just what we did up above. So if that is 1, what is the leg across from the 30-degree angle is always going to be? It's always going to be 1/2. And what's the leg across from the 60-degree angle going to be? Radical 3/2. So right here, these are, you got to know these. These are the building blocks for kind of about everything we do from here on out. So that's 1/2. That's square root of 3/2. If I flip it, the side across from the 30-degree angle is 1/2. Then that leg is radical 3/2. Okay. So instead of having, I think we had 2 as the hypotenuse, 1, and then square root of 3 is going to be 1/2 and square root of 3/2. All right, what about for 45, 45, 90? I want the hypotenuse to be 1. What are the legs going to be? If it is 1.
Square root of 2/2.
They will be square root of 2/2. Now, if you're saying, how did he get that? Okay. If you get a 45, 45, 90, remember, if the angles are equal, then the sides have to be equal. So what you can do, and we can solve it using Pythagorean theorem, x squared plus x squared equals 1 squared. Well, x squared plus x squared is 2x squared. 1 squared is 1. Divide by 2, and I get x squared equals 1/2. Take your square root. Square root of 1 is 1 over radical 2, but then when I rationalize the denominator, you get square root of 2/2. So for a 45, 45, 90, okay, this one here, make sure that if the hypotenuse is 1, then your legs are radical 2/2. Make sense? All right, now let's go down to that bottom left figure. This is going to help us to create some of these values. Now you only have that line in the first quadrant to begin with. If that's a 30-degree angle, what we need to know are the coordinates of that point, okay, on the circle. That's a unit circle, so the hypotenuse is 1. Okay, Aaron, do you know the points, the coordinates of that point?
1/2 square root of 3/2.
Close. Why don't you switch the order?
Square root of 3/2. 1/2.
Square root of 3/2, 1/2. Now, here's what's going on. Drop the perpendicular. Create a 30, 60, 90 triangle. What is the side across from the 30-degree angle? It is 1/2. What is the side across from the 60-degree angle? It is square root of 3/2. So we go over square root of 3/2, we go up 1/2. Now, from this one, we can get 3 other angles. We want to create a triangle. All those triangles need to have a reference angle of 30 degrees. So draw in that, and then this is 30 degrees. In each of these reference angles, will be 30 degrees. And we're going to get the same thing when I draw in the perpendicular. You're going to get 1/2 for the leg across from the 30-degree angle, and then the horizontal leg will be square root of 3/2. All right, what is that actual angle for this point? 30 degrees is a reference angle, but what is the actual angle that you're taking? All right, Kenzie, is that making sense what I'm asking?
No.
No? Okay. This line right here has a reference angle of 30, right? What would this angle be if we measured it from the positive x angle to there?
150.
So 150 degrees is that angle right here. And this point will now be negative square root of 3/2, positive 1/2 because we're in quadrant 2. So we're going to keep moving down the line here. 30 degrees, same thing. What would that angle be? The other one was 150. What would that one be if we went past 180? We went another 30 degrees past it. Mr. Schmerber.
Oh, no, the reason.
Oh, yeah.
Oh, really?
Yeah.
Yeah. Oh, I don't know. I just saw this board.
All right, what would that mean? What would that angle be? Mia, did you hear me?
I was just hearing you.
Yeah.
I'm sorry.
You didn't respond. What would this angle be in here, quadrant 3?
110.
Say that again?
110.
210?
Yeah.
Yeah, okay, it sounded like you said 110. Nope. 210, what would be its coordinates? Negative square root of 3/2, negative 1/2. Okay, so that's 210. And then this angle here is going to be 330 degrees. Drop that perpendicular. So basically, you're going to get a little bow tie look for all of those. And now that's going to be square root of 3/2, negative 1/2. Because all of these triangles are going to have the leg across from the 30 degrees to be 1/2. All right, flip it over. Flip it over. Okay, we're just going to fill in a little bit here. We're not going to get done with the whole thing, which is okay. Okay, so right here. On the inside here, these are the degrees. 0, 30, 45, 60. So everything, it goes up in those increments. Once you get to 30, then it goes up 15 degrees and 15 degrees. And now, at the top, it's going to be 90. Whoa. 90 degrees. And then what's the next one after 90? Okay, go another 30. It's going to be 120, 135, 150. And then we get 180, 210, 225, 240, 270, 300, 315, 330, and then right underneath that 0, it'll be 360. So 0 and 360 are equivalent. All right, do you know what the radians are? Can you fill in the radians without doing any work? I can do 0 degrees. I know that's 0 radians. 30 degrees, pi over 6. 45 is pi over 4. 60 degrees is pi over 3. All right, from there, it's all multiples. So I'll take a second and see what you can fill in. All right, so let's just finish. Once we get these radians in, then we'll come back and finish the rest here next week. 90 degrees, pi over 2. 120 is a multiple of 60. 2 times 60, 2 pi over 3. 3 times 45, 3 pi over 4. 5 times 30, 5 pi over 6. 180 degrees is pi. 210 is 7 times 30, which is 7 pi over 6. 225 is 5 times 45, so it's 5 pi over 4. 240 is, what is that? 4 times 6? 4 times 6, which is 4 pi over 3. 270 is 3 pi over 2. 300 is 5 times 60, which is 5 pi over 3. 7 times 45, 7 pi over 4. And then 330 is 11 pi over 6. And 360 is 2 pi. All right, so for that first circle we did, we got to come up with the coordinates. I'm only going to do the 30 degrees. What's the coordinates at 30 degrees? We just did it. It's pi, radical 3 over 2 is the x, and 1/2 is the y. And then which ones are equivalent? There's all the reference angles are 30. So 150 degrees is negative square root of 3 over 2, positive 1/2. And 210 is negative square root of 3 over 2, negative 1/2. And 330 is square root of 3 over 2, negative 1/2. All right, we'll stop there. We'll finish Monday. My apologies, no homework. Okay.
Yeah, I was hoping, I figured that might be where you were going with that.